This is the video going over the March 31st assignment, which is over composite volumes exercise A. We're going to start off with question number 1. Number 1 says, James bought 2 ice cream cones from Rod and Rolls for his kids. What is the volume of the ice cream used to fill both cones? As we can see, we have 2 ice cream cones with ice cream inside. So we're just going to worry about finding one of these shapes. As we can see, we have 2 3D shapes. We have a hemisphere right here, and we have a cone right here. So we need to find the volume of both shapes. So let's start off of finding the cone. All right. So the volume formula for the cone is 1/3 times big B times the height. Now big B stands for the area of the base, and if we remember, the shape of a base for a cone is a circle. We have a circle right here. All right. So the area formula for a cone is, or a circle, is pi radius squared. That's the area formula. Okay. So let's rewrite our volume formula, but instead of big B, we're going to write pi radius squared. And we'll drop down the height. Okay. So there's our volume formula for a cone. So when we look at this volume formula, we know we need to find the radius and we need to find the height. We see that 6 right here is going from side to side of this cone right here, or the circle, okay? So that means 6 is our diameter, so our radius is half of 6, so our radius is equal to 3, all right? So we have volume is equal to 1/3 times pi times 3, 3 squared. Let me erase this a little bit. Times the height. We have to find the height of our cone now. If we're talking about just the cone, we want to know what goes from here all the way down to the bottom, which we can see is 13. So times 13. All right, let's go plug all of this in our calculator real quick. So we have control divide for 1/3 times our big B, which is pi, times the radius of 3 squared. We'll put in parentheses. Times the height, which was 13. And we get 122.5. Okay, so volume is equal to 122.5 centimeters. And we're talking cubed. Our answer is going to be cubed because we talked about volume. All right, so there's our cone. Now we need to find the hemisphere. To find a hemisphere, though, we know a hemisphere is half of a sphere, so we need to find a whole sphere first of ice cream and then divide it by 2, okay? So for the hemisphere, our volume formula is volume is equal to 4/3 times pi times the radius cubed, all right? So in our volume formula, we don't have a big B. So in our volume formula, we see that we need to find our radius. Again, our radius is going to be the same thing as the cone. Our radius is half the sphere, which is 3. All right, so we have 4/3 times pi times 3 cubed. All right, let's go to our calculator and plug that in. Control divide. 4/3 times pi times 3 to the power right here, power of 3. We get 113.097. But remember, we found a whole sphere right here. So to find a hemisphere, we need to divide this number by 2. So let's just divide it by 2. So our hemisphere is 56.5. So our hemisphere is volume is equal to 56.5 centimeters cubed. That's our volume for our hemisphere. That's our volume for our cone. And now we need to add the 2 up. Okay, so we have 122.5 plus 56.5. When we add these up, so let's go, we'll add this number plus this number. we get 179.071. Okay, so when we add them up, we get 179.0. What was that? In 700s. Okay. All right, so we get this number. But remember, this is for one cone only, and we have two. So we need to take this number and multiply it by 2 now. Okay? So let's take this number. We're going to multiply it by 2, and our answer is 358, and we'll say in 1/10. Let's go back to our problem. And we can see that answer choice B is going to be our closest answer at 358.3 centimeter, and it's cubed. All right. So that's question number 1. Let's go to question number 2. Number 2 says, below is a block with a cylindrical hole. What is the volume of concrete used to make the block shown below? All right, when we look at this, we see two shapes. We see a rectangular prism. So I'll write rectangle over here. We have a rectangular prism there. In our second shape, we see a cylinder on the inside for the cylindrical hole. So cylinder, CYL. Okay, so let's start with our rectangle. So our rectangle, our volume formula for our rectangle is volume is equal to big B times H, right? Big B is the area of the base. For a rectangle, the base is always what it's sitting on, which we can see is this rectangle down here. All right. So for the area of the base for a rectangle, it's length times width. So let's go in our formula and change big B for length times width times the height. Okay, we drop down the height. All right. So we can see the length of this rectangle is 10. So we have 10 times our width of 14 times our height of 12. Our height is 12 because we have a base on the bottom and the base on top, which is 12 inches away apart. So we have 10 times 14 times 12. And we get 1,680. And we're see it's 1,680 inches cubed. All right, so there's our rectangle volume. Now we see we need to find the cylinder now. So the cylinder, we have volume is equal to, it's the same formula as the prism, big B times H. But the only difference is the shape of the base for a cylinder, as we can see, is a circle. All right, so we're going to replace big B with the area formula for a circle, which is pi radius squared times, drop down the height. All right, so we need to find the radius of the cylinder and the height. As we can see, we have this line right here that goes halfway into the circle is pointing to 2. So 2 is our radius, and our height for the cylinder goes from the top all the way down to the bottom, which is the same length as our prism, which is 12. So now we have pi times 2 squared times 12. When we plug that into the calculator, we have pi times 2 squared, and we're going to multiply it by 12. We get 150.8 tenths. Okay? So now we have these two numbers. Here's our volume for our cylinder. Here's our volume for our prism. Now we see that it's a hole inside the prism. So we're not going to add the two. We're going to subtract the two. If we see one shape inside of another shape, we subtract. Okay, so we have 1,680 minus 150.8. All right, so we subtract those two, and when we subtract those two, we get 1,528.8 inches cubed is your answer for number 2. Okay, so next question we're going to go to is question 4. All right, number 4 says, the foam pyramid below has a hole shaped of a cone. What is the volume of the foam? All right. As you can see, we have a pyramid and a cone. So those are our two shapes. So I went ahead and wrote our formulas. As we can see, they use the same formula for both of them. The only difference is we're going to replace big B for both of these with the area or the area formula of their bases. Okay. So let's start with pyramid. So for our pyramid, we can see the shape of our base is a square, 9 by 9 square. So the area formula for a square is length times width, okay? And we drop down the height, so times height, okay? So we have 1/3. Our length of our square is 9. Our width of our square is 9. So we have 9 times 9 times the height of our height of the pyramid, which we can see is right here, and it goes all the way down to the tip of the pyramid, which is 8. Okay, so let's go plug this into our calculator. Control divide. 1/3 times 9 times 9 times 8. We get 216. So the volume of the pyramid is 216 meters cubed. All right, so that is our pyramid. Let's go over to our cone. For our cone, the shape of the base for a cone is a circle. We can see our circle right there for the cone, okay? Let me outline it. So for our cone, we have pi radius squared times the height. All right, so 1/3 times pi. What's our radius for this one? We can see that this 6 is pointing at this line going from side to side. So half of 6 is 3. So our radius is 3. We'll square it times the height of the cone, which we can see is the same height for the pyramid. It goes straight down from the base of the cone to the tip of the cone, which is also 8. All right, so let's go plug this into the calculator. We have 1/3 times pi times radius is 3 squared times our height, which is 8. And we get 75 point, we'll say 4. So we get 75 and 4/10 meters cubed. All right, so as we can see, there's a hole inside the pyramid. So we're not going to add the 2. If we see a shape inside of another shape, we subtract the 2. So we have 216 minus 75.4. So let's subtract those two real quick. So we have 216 minus, let's go up and hit enter. Enter one more time. We get 140.6. As we can see, is answer choice C. Answer choice C is the correct answer for number 4. Let's go on to question 6. Number 6, Crayola made a jumbo crayon container for Valentine's Day candy. What is the volume of the container? All right, when we look at this composite figure, we can see that we have a cylinder and a cone, all right? So I went ahead and wrote out our volume formulas for both. Let's start off with our cone. So volume is equal to 1/3, and let's replace big B with the area of the base. As we can see that the base of this cone right here is a circle, all right? So the area formula for a circle, pi radius squared, times the height of the cone, or height of the 3D cone, all right? So we're just worried about the cone right now. So the radius of the cone, as we can see, we have 3 pointing at this line going from the center of the circle to the edge of the circle. So 3 is our radius. 1/3 pi times 3 squared. Now we need to know the height of just the cone, which we can see from the tip of the cone to the very base of the cone, which is the circle. We have 4 inches, so our height is 4. Okay, let's go type all this in our calculator. Control divide. 1/3 times pi times 3 squared times our height of 8. Was our height 8? Sorry, our height was 4. So let's go back up. We get 37 point, we'll round up to 7/10. So our volume is 37 7/10 inches cubed. All right, so there's our answer, our volume for the cone. Now we need to find the volume for the cylinder. So big B is the area of the base, which is still in the shape of a circle. So we have V is equal to pi radius squared when we drop down the height. Okay. The cylinder and the cones share a same base, so that means they have the same radius of 3. So volume is equal to pi times 3 squared times the height. Now the height isn't here because we're finding the height of the cylinder. So if we have a base over here, which is a circle of the cylinder, we have another base of the cylinder here. So we can see that they are 7 inches apart from each other. Okay, so times 7. Let's multiply all this together. So we have pi times 3 squared. And we're going to multiply this number times 7, which is the height. We get 197 and 9/10 if we round. Okay, 197 and 9/10 inches cubed. All right. Now we have the volume of both our 3D shapes. So as we can see here, they're side by side to each other. They're combined. All right. They're not inside each other. If they're side by side, we are going to add them instead of subtracting them. So we're going to add 197.9 plus 37.7. When we add these two up, we get 235 and 6/10. And we can see answer choice C is going to be the closest answer to that. So C is the correct answer for number 6. The last question we're going to do is question 10. All right, question 10. We have find the volume of the solid shown below. As you can see, we have two, looks like square pyramids because this side right here is 3 and this side is also 3. So if we have two common side lengths, we know this side's 3, this side's 3, so we have a square pyramid. We have 2 of them. So let's find the volume of one square pyramid and we'll multiply it by 2 at the end. Okay, so square pyramid. The volume formula for a pyramid is 1/3 times big B times the height. As we said the shape of the base is a square. So here's our square. All right. The volume area formula for a square for big B is length times width. So we're going to replace big B with length times width. And we'll drop down to 1/3 in the height. The length is 3. The width is 3. And our height for our 3D shape, as we can see, is if we go down straight down to the center of our base, over here it says it's 2. All right. So let's rewrite it. We have 1/3 times 3 times 3 times 2. All right. When we hit enter, we see that it's 6. But remember, we have 2 of these square pyramids. We have this top one and the bottom one, which are identical to each other. So we can take our volume of 6 and we can multiply it by 2 square pyramids. So our final answer is going to be 12 feet cubed, which is answer choice C. All right. So that is going to complete the video for the March 31st assignment. If you need to redo the makeup assignment, go ahead and click on that and start on that.